The objective of this lesson is to use a T-chart to organize thinking as we create lists of factors of a given number in the range of 1 through 100. In previous lessons, students found factors with Cuisenaire rods and building arrays with square tiles. In this lesson, we will be using multiplication facts and division strategies to find factors. We will begin by drawing a T-chart. At the top of our T-chart, we will write the number to be factored. In this example, we will factor the number 24. Every number has a factor pair of 1 and itself. The numbers that are directly across from each other on the T-chart are the two factors that are multiplied together to produce the multiple, or the number being factored. Next, is the number divisible by 2? If it is divisible by 2, the number 2 would be a factor, and the other factor would be half of the number being factored. The factors are 2 and 12. Let's continue on with the number 3. Can 3 times a number equal 24? Yes. 3 times 8 equals 24. Therefore, 3 and 8 are factors. How about 4? Is there a number we can times with 4 to get 24? Yes. 4 times 6 equals 24. 4 and 6 are a factor pair of 24. Now we have come to a place where the gap between the pair factors is closing in. This is how we know to stop checking numbers. The closed gap can be formed in one of three ways. The first way a closed gap can be formed is by having two consecutive numbers. For example, in the number 30, the factor pair of 5 and 6 are consecutive numbers, and no other whole number factors exist between those two numbers. The second way a closed gap is formed is with two numbers of the same value. In this example, 36 has a factor pair of 6 and 6. The last way a closed gap is formed is when no other factors exist between the last pair on the chart. We only need to check factors up to and including 10 when finding factors of numbers less than or equal to 100. We can now see that the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. We can use a T-chart to help us solve a story problem such as this. The flower shop has 42 roses to use in floral arrangements. How can the roses be arranged in vases so that there is an equal number of roses in each vase? We will draw a T-chart and put the number 42 on the top. We know that 1 and 42 are a factor pair. We can then ask if 42 is divisible by 2. It is. 2 and 21 are a factor pair. 3 and 14 are a factor pair. 42 is not divisible by 4 or 5, but it is divisible by 6. 6 and 7 are consecutive numbers and therefore the last factor pair. We can say that the flower shop may have one vase with 42 roses, 2 vases with 21 roses, 3 vases with 14 roses, or 6 vases with 7 roses. We also know that we can include the opposite or reversed facts of vases of roses to include 7 vases with 6 roses, 14 vases with 3 roses, 21 vases with 2 roses, and 42 vases with 1 rose in each vase. The objective for this lesson was to organize our thinking and create a list of factors. We met this objective by creating a T-chart and using multiplication facts and division strategies to find factors.